and welcome to the second tutorial in this three-part mini-series on algebra. And in the first of these we looked at what I called the unwrapping, the expansion of brackets. And now really we're going to look at factorisation in this tutorial, which is essentially the opposite process of wrapping. And as I stressed in the first tutorial, with that metaphor of wrapping and unwrapping, we're more concerned with the mechanics of it, the paper, the scissors, the tape. We're not so worried about what's inside the box. So don't get distracted by what does the symbol mean. This is more about manipulation. And factorisation, to be honest, doesn't really give you generally new insights. Sometimes it does. It's often just a way of tidiness. It's about presenting results in a compact, tidy manner. And that's just common sense. We do that in every part of our lives generally. You know, we don't have too much excess. For example, when you write your postal address, you try to keep it to 3 or 4 lines. You know, you don't have 20 lines in your postal address, and it's sort of similar here, that we want to just make things nice and tight and compact. Sometimes though we do get insights from factorising, particularly when we're factorising so-called trinomials, because that's a topic that we'll see again in some tutorials on quadratic functions that are coming up, and I will talk a little bit about that in the second half of today's tutorial. So let's start at the beginning though. Let's do some nice simple examples. So this is about the wrapping part. So let's imagine I have 5 plus 10y. So I have two terms added together. What I'm looking for in factorisation is, are there any common factors? And indeed, we know that 10 is 5 times 2, so 5 is actually a common factor between these two terms. And I can write this, taking that common factor outside, putting in a bracket, and saying 1 plus 2y. And the nice thing about factorisation is you can always check by just unwrapping. So it's like you're wrapping presents for yourself. You can just unwrap them again and see if you've got the same thing in your hands that you had before you started wrapping. If you don't, you've made a mistake. So 5 times 1 is 5, 5 times 2y is 10y. That's absolutely fine. Let's do another example. 3a plus 7ab. What is the common factor between these two terms? Well, 3 and 7 definitely don't have any common factors. B only appears in one term. That's no good, but obviously A is a common factor, so we can take A outside, and then we have 3 for the first term, and the second term we have plus 7b. Okay, and so that's a way of factorising that particular expression. Let's just do one more example. Let's imagine we have x squared minus ax and then plus 2x cubed. Okay, common factor here is x. So we could just take the x outside. We can't take x squared outside because this term only has one power of x. So if you have terms that have different powers of the same base, if you remember our terminology from the indices tutorial, you can only take outside the power of the base that has the lowest power. Here it's x to the power of 1. So we can take x outside. Then to get x squared we need to have x. To get minus ax we need minus a. And to get plus 2x cubed, we'll need plus 2x squared here. And again, we can check if we wish to make sure that that's going to give back the thing that we have just wrapped up. Now, let's just remind ourselves in reverse of these very useful expressions. A squared plus 2ab plus b squared. Remember, we saw how to get this from unwrapping, and it comes from a plus b times a plus b, which you could write as a plus b squared. I'm just leaving it as two repeated brackets just to make clear how these are related. Remember, we have a times a is a squared, we have ab plus ba is 2ab, and then finally plus b squared. Similarly, a squared minus 2ab plus b squared can be written as a minus b times a minus b, namely a minus b all squared. Again, we see a squared minus ab minus ba gives the minus 2ab, and then negative b times negative b gives back the b squared. Okay, and then the one that is not at all obvious, and you really just have to know this, the difference between two squares can be written as a plus b times a take away b. Not obvious at all, but we have a squared, we have minus ab plus ba, namely minus ab plus ab, which cancel, and then we have minus b squared. So these three are definitely ones to commit to memory, either going this direction or this direction. What these need to give you is sort of a kind of a sense of recognition. So let's imagine we were given something like x squared plus, let me just do this, plus 2x plus 1, for example. Do you see that this has the same pattern as this? If a represents x and b represents 1, this cross term would be 2 times a times b, 2 times x times 1. So we could immediately write this as x plus 1 times x plus 1. We wouldn't write the second bracket, we would just put squared there, okay? So x plus 1 all squared. I didn't write this as a plus b squared or a minus b squared, only because I wanted you to sort of see with both brackets there why they're the same. So you can sort of spot these things if you look at that pattern. So if we had another example, maybe let's say we had x squared plus 6x plus 9. Not so obvious, hey, but worth checking that if you have an x squared and you've got a constant, is that a square of something? If it is that middle term 2 times the thing that is squared here times x, and we see here it is. This is 3 squared, and this is 2 times 3 times x. So, with a bit of experience, you can see something like that and say, oh, that is x plus 3 all squared. Let's do a slightly trickier one. Let's imagine we had 16y squared. Now I'm going to have to do this a little bit slowly because I'm doing these on the fly. It's not the easiest thing in the world to actually just kind of make these up. Plus 100. And I think I would want to have something like 80y. Right, this one's definitely not so obvious, but what you can see here is that we have 4y all squared here, because 4y times 4y is 16y squared. Here we have 10 times 10. So 10 times 4y would be 40y, twice that would be 80y. So this actually can be written as 4y plus 10 all squared, okay? Which, then you can just check. It's easier once you've written it down to go back and say, yes, that does make sense. 16y squared, 40y twice is 80y, and then 10 squared. Now here actually we can do a bit better because we could have factored out immediately from here. Let me just show you actually. We could have immediately factored out a factor of 4, which would have made things a bit easier to spot then, because we'd have 4 times 4y squared. The 80y is 4 times 20y, and 100 is 4 times 25. And then we would see here, maybe a bit more easily, oh, that's 2y all squared, that's 5 squared, that's 2 times 5 times y twice over. So we have 4 lots of this bracket, which is 2y plus 5 all squared. These are the same thing. If we factor out here a factor of 2 twice over, because we have 2 brackets of 4y plus 10, so we get 2 lots of 2 factoring out gives us 4, and then we have 2y plus 5 all squared. So that's some practice with factorisation. These examples are kind of a lead up to the tricky but important topic of factorising trinomials. Okay, and let me motivate that by looking at an example. Not x plus 1 squared, but imagine, let's unwrap x plus 1 times x plus 2 and see what happens. We have x squared, we have plus 2x plus x is plus 3x, and finally we have plus 2. And so in this example, it's really, if you had never seen a factorised trinomial before, I think you'd be quite hard pressed to see pretty quickly that that can be factorised into 2 brackets. And this is a skill that is asked of you at this level of maths, is to be able to spot these factorizations of, this is called a trinomial, has 3 terms which can't be combined. That has x to the power of 0, x to the power of 1, x to the power of 2. I think what might be helpful here, let's actually look at the general case. The most general case would be x plus a times x plus b, where a and b here I'm just using to represent some integers. Okay, they can be positive or negative. Now if I multiply this out, I'm going to get x squared, I'm going to get plus bx plus ax. Let me actually just write that down. And then finally I have plus ab. The point I want to make here is that these 2 terms both involve x and can be factorised to a plus b times x plus ab. So if you're given a trinomial and asked to factor it, like the one we were given here, let's imagine we had to try and go backwards here. What you're really looking for are 2 numbers to put in, one in each bracket. In the trinomial, this number represents their product. You see how the a and the b end up as a product here in this number, and then the number multiplying x is the sum of these 2. So the way I could have gone backwards here is to say, well, the only way I can factorise 2 in terms of integers is 2 times 1. But hey, 2 plus 1 is 3, and therefore I can factorise this. So let's imagine we were given x squared plus, let's see, let me just make up an example quickly, 7x plus 10, okay? The strategy to go about this is to say, right, this has to be x plus something times x plus something. Now the 2 numbers appearing here, when multiplied, must give 10. Well, I can have 10 times 1, or I can have 5 times 2. If I had 10 times 1, I would have 10 here and 1 here, but 10 plus 1 does not give me 7. So let's look at the other example, 5 and 2. 5 times 2 is 10, and yes, 5 plus 2 is 7. The 2 times x plus 5 times x will give me 7x. Let's do another example. X squared plus 10x plus 16. Sorry for the pauses, I'm actually just making these up in my head, it's a little bit tricky. And again, it's going to be x plus something times x plus something. We want here and here two numbers that multiply together to make 16. Now that's a bit awkward because we could have 16 times 1, we could have 8 times 2, or we could have 4 times 4. So you could just look at them one by one. If this was 4 and 4, yes, the product would give 16, but the sum would give 8x, not 10x. If we had 16 and 1, the product would give 16, but the sum would give 17x. That's no good. If we have 8 and 2, it's just the ticket. The product is 16, and the sum of 8 and 2 is 10. X squared plus 2x plus 8x gives 10x plus 16. Let's look at an example where the middle term is negative and the last term is positive. Okay. In fact, let's just take x squared, take away 10x plus 16. And we're going to write it as x, and then I'm not even going to write a plus, I'm just going to write x for now. If you have this pattern of a plus x squared, a negative term and a positive term, it must be the case that both of these brackets have a negative. The reason that is that the only way this can be negative and this positive is for both of the signs here to be negative. You'll then have two numbers. I'll cut to the chase and say, yes, those are 8 and 2. Negative times negative is a positive, and we get our plus 16. But then we have negative 2x, negative 8x is negative 10x. So if they're all pluses, things are relatively straightforward. You're looking for two integers that multiply together to give this number and add together to give this number. If you have plus, negative, plus, you're looking for two numbers again which multiply to give this, essentially which add to give the positive bit, but when you write it as brackets you're going to have negative signs here. Okay. The tricky case is when you have x squared, you have some term here, but then you have a number here which is negative. Okay. Then things get quite tricky. So let me just make up an example on the fly here. Let me say I've got negative 2, and let me say I have plus x. Okay. If this last term is negative, it must be that you have one bracket has a plus and one bracket has a minus, because that's the only way you can have a final term here which is negative. You must be multiplying a positive times a negative. So again, we're looking for two numbers that can multiply to give actually this integer 2, and that would be 1 and 2. So we're either going to write a 1 here and a 2 here, or a 2 here and a 1 here. We have to get plus x. So I need to have a 2 here and a 1 here. Then you see I have x squared, I have minus x plus 2x, that gives me a net plus x, and then I have take away 2. If I had x squared minus x minus 2, then the thought process would have been very similar. We have an x and an x. We have 1 plus and 1 minus. We're going to have 2 and 1 as the two numbers that appear here. The order must be that we get a negative x, and so then I would need to have my 2 here and my 1 here. I have x squared, I have negative 2x plus x gives me negative x, and then minus 2. Let's just do a couple more examples. Notice that in all of these cases I'm taking the coefficient of x squared to be 1. At this level of maths, generally, if you're asked to factorize trinomials, you're not troubled with a factor multiplying the x squared. At a slightly higher level of maths, you do need to be able to factorize when you have an integer here. It becomes, slightly trickier. It's, again, a matter of experience. If you're being asked to factorize these things, it means that there are going to be nice brackets that represent it. If you were just given a random trinomial, the overwhelming odds are that you wouldn't actually be able to factorize it, and you would be using other methods then to make sense of it, as we'll see in the tutorials on quadratic functions. So for our purposes though, if you have a 1 multiplying the x squared, you're always going to have a bracket times a bracket where you just have x as the first term in each bracket. And then you just have these sort of rules of thumb that we've been talking about here above. So let's just do a couple more examples then. Let's imagine we had x squared, and again I'm just sort of doing this on the fly here. Let's say we had negative 6x and then negative 16. Okay, so because the final term is negative, we know we have x and x to get the x squared. We know we're going to have 1 bracket plus and 1 bracket minus, but we then have to do a bit more work. We have to say, well, what are the factors of 16? If they were, say, 16 and 1, I can put them as 16, 1 or 1, 16. If they're 4 and 4, I can just put them in. If they're 8 and 2, there are 2 different ways of putting them in. And you have to sort of play around until you find the right combination. So just for the purposes of time here, let's assume that we tried the 4 and 4 and the 16 and 1 in different combinations. The factors will actually be 8 and 2. I want negative 6x, so I need my 8 here. I need my 2 here, and you see I get x squared. Negative 8x plus 2x gives me negative 6x, and then minus 16. Okay. And let's just do one more example. Let's imagine I have x squared. Let me try and do this. Sorry for being slow here. Let's say we had plus 15x, and then we had take away 16. I'm being slow because I'm having to kind of go forward then backwards before I go forwards again in the tutorial. Right, so x and x, our old friend 16. It's negative, so there has to be a plus and a minus. 8 and 2 is not going to work because we're never going to get an odd number from 8 and 2 anyway, regardless of which order we put them in. 4 and 4 won't work because then we'd have the difference of 2 squares. So it has to be 16 and 1. And that sounds plausible actually, because 16 take away 1 is 15. We just need to put them in the right way. And we're going to put, we want plus 16. So I want 16 to multiply here. And then I want the 1 here. So I get x squared, take away x plus 16x. Gives me plus 15x. And then take away 16. Phew. Okay. So that's trinomials. We're going to see some more trinomials when we do the quadratic functions tutorials. So don't worry if you haven't quite really got the hang of these. We're going to be seeing a lot more of these as we go through quadratic functions. But generally, I hope this tutorial has been helpful in the wrapping part, the factorisation. And in the last tutorial in this little mini-series on algebra, the very, very important skill, expertise, technique of rearranging equations, which seems to be a real bugbear for students, but boy, it's so important. So I'm really going to try hard in that third tutorial to make it as clear as possible so that it becomes a skill that you're happy to have and are confident in using. So I look forward to seeing you then.